Welcome to the Alpha Training and Consulting's online training program. Today we're going to answer the question, what is a standard deviation? Please keep us in mind for any of your ASQ certification preparation needs. We've been preparing students for ASQ certifications for over 20 years, and we've become very good at it. So hopefully you'll consider us should that need ever arise. All right, let's get back to the question. What is a standard deviation? Well, a standard deviation, first of all, you take the majority of the normal distribution. To be exact, you take 99.73% of the normal distribution and you divide it into 6 equal lengths, as you see I have done here. 6 equal lengths. In other words, 1/6 the distance across the majority of the width of this curve. And we call that 1/6 distance a standard deviation, often referred to as sigma. Now, standard deviation really has two purposes in life. One is to let us know how wide a curve is. The width of this curve is often referred to as variation or variance. And so the bigger this 1/6 distance becomes, obviously it's a representation that the curve is bigger. So it's a measure of variation. Now, it also has another purpose in life, and that's it's a unit of measure of length. We always measure distance from the average in units of standard deviation. By the way, the average is always the reference for measurement. And so, let's say we said we had a 2 sigma process. What does that mean? It means from the average, the spec limit is 2 sigmas away. So the upper spec limit would be 2 sigmas away, and the lower spec limit, let's say it's 2 sigmas away also. That's a 2 sigma process, or 2 standard deviation process. You may have heard the term 6 sigma. What 6 sigma is the spec limits are 6 sigmas away from the average. So the upper spec limit is 6 sigmas away, and the lower spec is 6 sigmas away. So what's the purpose of standard deviation? It's a measure of variation. And what else? It is used as a unit of measure of length, a unit of length. Yeah, I know out on the shop floor you may measure in centimeters, millimeters, inches, or whatever, but in the world of statistics we measure distance in units of standard deviation, or sigma. So hopefully you remember that. That's very important. Now, of course, we could calculate the value of this standard deviation because I've given you 3 numbers here. We only really need 2 numbers, 8 and 2. And so if I go 8 minus 2, that gives me the distance across the width of that curve. And how many are there? There's 6 equal lengths, so 6 divided by 6 is 1. So the standard deviation for this distribution would be equal to 1. Obviously, every distribution has a different width, so you have to take that into account. By the way, also, when you're 3 sigmas away from the average, we call it a control limit. An upper control limit, 3 sigmas above the average. Lower control limit, 3 sigmas below the average. So remember that. That's important to remember also. As you see, I've labeled these numbers as control limits now. There's my 8 equals my upper control limit. 2 equals my lower control limit. So what would the formula be for a control limit? Well, it would be average. Upper control limit would be the average plus, how many sigmas? 3 sigmas. Very easy formula. And what would the lower control limit would that be? That would be average minus 3 sigmas. Now remember, on this particular distribution, we calculated the standard deviation to be equal to 1, or sigma was equal to 1. So now let me explain the property of the normal distribution. It's very predictable. This is how predictable it is. Remember, sigma is equal to 1, so if I go 5 and I go out 1 sigma, this would be 6. This would be 4. And if you go out plus minus 1 sigma on a normal distribution, that's where 68.26% of the population would lie. So on this distribution, between 6 and 4, that's where 68.26% of this population would lie. If you go out plus minus 2 sigmas, there you go, plus minus 2 sigmas, 2 sigma distance, which is what? 5, 6, 7, and 5, 4, 3. So between 3 and 7, that's where 95.44% of this population would lie. Now you can go out 3 sigmas plus minus 3 sigmas, which means 5, 6, 7, 8. There you go. 5, 4, 3, 2. And plus minus 3 sigmas, that's where 99.73% of the population would lie. So in this population, between 2 and 8, that's where 99.73% of the population would lie. Well, hopefully you learned something new today that will help you in your career. Remember, keep us in mind should you ever need any help getting ASQ certified. Thank you, and have a great day. Goodbye.